Right. So I believe we have started streaming. Yeah, so there was some delay there. But yeah, so as I said before, good morning everybody. Welcome to DJ Raul's physics class, and this is another episode in our grade 9 uh physics class series where we focus on topics that will be which will be on the exams coming up. Coming to the close of the school year. Now it's June, so this is in fact the last month, really, of should we say of school, and with end of year exams around the corner, these are some questions which are very likely. So those of you who have been following, thumbs up. Those of you who have not followed, then it would be in your best interest if you are a grade 9 student and this bill fits you. Of course, this is geared towards grade 9 students at Belfield, and so it might be different for other schools across the um, parish or across the island of Jamaica or throughout the Caribbean. However, this topic does turn up as a major one on CXC syllabus. So this is laying the foundation for students who plan to choose CXC physics in fourth form, which is a couple months from now. So with that said, we will be continuing on the topic that we did last week, and we looked at some questions, and I tried as much as possible not to give the answers, and so I didn't give the answers, but I did discuss the questions. So hopefully this week you'll be able to tell me your answers. All right, so those of you who are following, um then you can feel free to participate. And I remember last week I actually had a class. Well, I had another class last week. It was about yeah, I think it was a grade 10 chemistry class, and then there were some students or some persons online who were giving me some answers, but then they were well, I was not seeing the answers, so you know sorry about that. But I had made a comment on the video about seeing them subsequently. I saw the questions after the stream, and then I responded. So yeah, no so yeah, at the moment we just basically trying to reach out to um grade 9 students at Belfield. They haven't joined the room as yet. Hopefully we can send a shout out, and they will be there. So I don't know what's happening, but let's see the thing there. And I'm definitely gonna paste this stream. This is a link here, and it should. It's an invalid link. That's an invalid link. All right, let's just go back to the stream, because this creates some issues. The stream link is often not accepted in the Google Classroom, but let's see if it works this time around. All right, so add the link, and then students should be able to follow us here. So all right, so we're gonna post this. All right, as well as at the end of the class, the video will be uploaded. So those of you who choose to follow, then it's there. All right, so guys, yeah, here we are. So going back, and just to recap in the previous class and what we did. If you're seeing the question, all right, yeah, you should be seeing it. All right, so looking for the chat or persons to respond here. All right, so here we go. So this question, as you can certainly see, this question is asking about the length of a feather, and we certainly did this last week, and we were saying that okay, the way to approach this question would be to start where the feather starts and end where the feather ends, and count the numbers in between. No, I gave this activity to some grade 10 students, and unfortunately they weren't able to reason out what happened there. I'm wondering if they were not seeing the numbers here, and and it's clear. I'm not certain if there's a problem with students reading numbers, but the numbers should be clear. You know, it's just to look at it and see that that is what it is. So this number here is 10, and it means that these numbers here would be counting up to 10. So if this is 10 here, then this will be 9, this will be 8, 7, 6, 5, 4, 3, 2, and 1. And of course, it starts from 0. So, but then the feather wasn't placed at 0. Feather was actually placed where they placed it. They placed it at they placed it at 1, or rather at 10, and then it went all the way up to 29. So the difference there between 10 to, if we count from 10 to 29, then we should easily get our answer here. So it's 10, 11, 12. And when we do all of this counting, we should end up with we certainly should end up with the answer of 19, because it would be 29 minus 10, which would give us 19. Okay, so that would be the answer for the first one. All right, so if you have any questions, just feel free to stop me or interject. You can also raise your hand using the features in the room as well. All right, by the way, this class is also accessible by Zoom. So I'm gonna post that link as well along with the stream here. So it's definitely
in progress.
Certainly it's recording there. But
recording stopped.
Yeah, definitely wanna show something here. All right, definitely share recording participants here. We invite, and so yeah, it should be streaming now as we speak. All right. All right. So while we sort out that, there should be a stream link here. There's a okay. Let's copy the link here. All right. So we're gonna go into the classroom and we're gonna paste this link. And let's edit this. You can get a link. Here's the link. Paste that in. And the link. All right, there you go. All right, so well, that is well, that link is being sent because there you go. All right, so now here we are now, students. So we agree that when we count from 10 to 29, we end up with 19. So this will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. The answer there is certainly going to be 19. All right, so again, here we go. 19 is our answer. The answer there is C. All right, so just check your answers against what we you would have had from last week. All right. Question 2 said a student wishes to find the volume of a small irregularly shaped stone. Last week we explained what an irregularly shaped stone um was. All right, let's go. Remember that in terms of shapes, we looked at there are two types of shapes. So we have our regular shapes, and of course we have our irregular shapes. All right, and so this is a concept that you're expected to know. So regular shapes um are basically easy. You call them these, rectangle, circle, square, triangle. All right, so and we show you some images of those. You should be able to identify them. These are our regular shapes, and you should be seeing this. All right, so let's go. Let's bring this up on the screen. Bam, here it is. All right, so all of our regular shapes here. Um, of course, we call them polygons, but it's an important thing. Be nice to know all of these math terms about angles and so on, but that's not our focus here. We could simply remove all of this and focus on the shapes and the names. And there you go. These are your regular shapes. So let's write regular shapes up here. And the regular shapes will be what you see in there. Regular shapes. All right, so regular shapes. And then of course we have our irregular shapes. So let's have a look at irregular shapes, and you should have an idea what we are talking about. All right, so here we are, irregular shapes, guys. Lots of them. And here goes our irregular shapes, guys. All right, there we go. Bam. Those are irregular shapes. All right, these are irregular shapes. This is ridiculous. All right. So while this all right, so there we go, guys. Our list of irregular shapes. Now, irregular shapes, and of course we have our solids. So let's get that out of the way now. Um, we have shapes and we have solids. In fact, let's introduce some solids into this category here. So then inserting what we could insert 3D models, and then there's some stock ones. So into those 3D models. Taking a while to load, but okay, fine. And look at this. We have our and there you go. We have I got this one. It's interesting. We're inserting a 3D model here. It's an interesting feature in the PowerPoint. As you can see here, this is just the Earth, and you can see they're moving. Um, I think in this online platform, though, students, I think there are a lot of features that are available, and I'm simply using Microsoft PowerPoint, and also I'm using the StreamYard for the streaming. But with that said, you know, this is a shape of. I'm pretty sure you know what this is, what this is representing. All right, should be look at that. All right, this nice and round. All right, so this would be a solid, and so when you have a 3D shape, when we usually we don't call it a shape anymore. We call it, well, if it's a 3D shape, it's no longer considered to be a shape. It's rather deemed or termed as a solid. So it's a called a solid figure. So this is a regular solid. So regular solid, and specifically, and this will be a sphere. And so if it's a sphere, it's a regular solid. But then let's see if we can get some other stuff in this. We can get some other devices that are actually irregular, and we can actually look at this, see if we can find something now. This is so interesting here. Here we have it. Let's bring a stone into this picture here, because the question does ask about a stone. Interesting to see the stone here. Again, let's move this regular side over there, and again we have the ability to turn it around, and hopefully you can find Jamaica. Does it have a zoom feature? Can we zoom in? Hey, there you go. We're actually getting closer into it. And just sphere there. All right. So certainly we're seeing Jamaica here. And if you guys know what Jamaica looks like, it's that we zoom all the way in. But if I put a a little mark right there that highlights Jamaica, and that's where we are at the moment. Quite interesting indeed. And maybe asking, what are those arrows going around? Well, these appear to be areas of pressure. It's really air, masses of air that's above the water. That's these well, these are areas of whether high or low pressure. I believe this would be high pressure though, if memory serves me correctly. These are currents, and of course winds are continuously blowing, and in this region, and so this at the start of our hurricane season will sort of determine whether storms or hurricanes reach our way. So quite an interesting thing, and this out of this comes from our knowledge of a simple sphere, which is a regular um solid, and it's a circle in 3 dimensions, a circle in 3 dimensions, and then I mean in 3D, a circle in 3D is a sphere, and again in 3 dimensions, and the 3 dimensions, by the way, for those of you who don't know what we mean by dimensions, all right, dimensions simply refer to the length which we are measuring how many objects today, but the length, the width, and the height. So let's go. Length, width, and height. So can we find these? Yes, we can. We should be able to find it. The length is the longest side. Problem with the circle is that maybe the length and the width is the same. All right. So this would, like, for example, be the length. In fact, maybe I should use a black marker to highlight that. All right. Let's get rid of that. Yeah, certainly do want this. We're gonna go with black, and so we can show you that what or we use a line, and it's even a better thing to do here. We use a line, and we're gonna insert a line, and we will show you where is it exactly we're talking about. So look at that. You should be seeing this line, and let us just make this line very big. Can format it, and we can increase the well, we can change the color. So let's use a black line, and let's increase the size of the line. There you go. It's 1.75. There you go. So we realize that, okay, so this is the length. Okay, and then we're not finished with the shape yet. This will be our length. So let's call this length. This is actually moving around, which is what I don't want. This pen, again, yeah, it should be straight again, and that 9 here. All right. We could also do some other things here. Let's just duplicate this, and we can turn this around to measure the width. The width is again the length of the widest side, and of course the earth is the example here. And then of course we have the height. Um, so the length, the width, and the height. It's interesting. We have a distance going into, and so this is tricky. So with 3D modeling, and this is one of the things that students need to understand. There are actually 3 dimensions in this circle. There's a part of the circle that goes in, and look at this. So there you go. So this actually going into the sphere. So if we were to cut it, we would see it. It's kind of like having an orange, all right, and you cut the orange, and let's change this here. Yeah, so it's like kind of having an orange, and you cut it, and unfortunately, I don't have anything circular here. At least not around me, but I will have one next time. All right, so there you go. So the length, the width, and the height. It's when a circle is in 3D, it becomes a sphere. And of course, this is our stone, which is again an irregular shaped solid. All right, irregular shaped solid. All right, so let's move this, and let's see if we can turn this around as well. Look at that. Irregular, so irregular. Nothing consistent about this. So irregular. And this is our stone. All right, that we can, rotate and everything. All right. So as a rule, a regular side sphere, and the amount of space taken up by a sphere, we call that something else, huh? Space taken up by a solid. Yeah. Space taken up by a solid. I don't know why this is not. Space taken up by a solid in 3D is called volume. All right. Space taken up by a solid in 3D is called volume. All right. So, all right. So now, next point is that regular solids have a mathematical volume, have a volume which can be calculated. And irregular solids have which can be determined by displacement method. Displacement of water method, guys. That's what we're saying here. All right. So, and we are definitely going to highlight this because it's so important, students. I would really like for you to remember this: the displacement of water method. It's used to measure the volume of irregular solids. So let's pluralize this here, and so that is our concept here. All right. Now, what they asked in the previous question, and why we ended up here, was that okay, we got a question, and here it is, a stone, and the same stone that we showed you, 3D, and a ruler and a measuring cylinder containing some water are available. Which apparatus is needed? All right. Now, for the stone, the volume, and notice I will underline this word because volume. Now you know what volume is. All right. Volume is the space of an object. All right, in 3D. All right, 3D. 3D means what? Three dimensions. All right, dimensions. All right, dimensions refer to the length, the width, and the height of the object. So I hope you guys would remember that. All right, so again, volume is a space taken up by an object. All right, volume is a space taken up by an object. All right, in 3D. All right, so it's 3D. So therefore, and 3D stands for 3D stands for length, width, and then of course our height. All right, so let's just bring this up on the screen so that you guys can see it and always remember it. All right, let's press enter and we will show this. All right, so yeah, volume is a space taken up by an object in 3D. All right, the three dimensions would be length, width, and height. All right, so there you go. Just a point of information there. All right. No. So from today's class, even though we didn't finish the entire paper, but the objective is more that you learn something related to what is on the syllabus. It doesn't have to be my plan because my plan was to finish the paper, but at the end of the day, I saw where there is some information that you would need to know so that we can apply it to other questions. Remember that once you see a question, the likelihood of seeing it again is very low. It's not likely that you're going to see the same question again because there are so many ways to ask a question. And so by discussing questions and going into things related to a particular question, then we end up with new questions and of course new information, which is still on the syllabus. So guys, I hope that you learned something from today's class. I would like you to remember from today's activities, okay, how to use this ruler in this specific case to measure the length of a feather that is placed against it. All right, and of course, we're looking at objects of irregular shape, and we also learned that irregular shapes in 3Ds are actually solids. All right, all shapes in 3Ds become solids. All right, and that's because, well, solid means what? It's stationary, solid, stay put, yeah, firm, maybe. But once you can go around an object and it does have an appearance then in three dimensions. Remember that if I draw a circle on the screen and let me just place it so you can really see what I'm talking about here. I'm like literally gonna place a circle here. And if you realize that the circle is just on a flat plane, I can't turn it. I mean, it can rotate this way, but can it go in? Whereas if I go to the sphere now, then you'll see that, well, I have options here. The solid can be rotated. Let's bring it up back here. All right, look at that. It can be rotated. See it? It can go left, right, up, down, and it can go all around, guys. So these are the three dimensions that a solid has. All right, guys. So that's just a simple recap of what we did. Um, so that would be it for today. All right. Again, remember that these are similar questions to this would appear on exam. So you might want to go through this material, and I'll let it be available in the classroom. Or if not, you could watch the video, play it back, and see what this is all about, guys. All right. So again, a student wishes to find the volume of a small irregular shaped stone. All right, you should come to me next week to tell me how that is done. And remember these important informations about the objects that we looked at. That volume is the space taken up by an object in 3D. All right, and also regular solids have a volume which can be calculated, and irregular solids have a volume which can be determined by displacement of water method. All right, so there you go. All right, that's it for our class today, guys. And I'd like to thank you for joining us, and hope that once again you learned something, and you can come next week to um at least remember to share with me what you learned from today's class. All right. Remember, now class is accessible by Zoom and also by YouTube, and so it's streaming at the moment. So, guys, have yourselves a wonderful day and stay safe. Peace.